Find the following of the polynomial: the zeros, the multiplicity of each zero, the degree, the leading coefficient, the end behavior, and the y-intercept. Use this info to sketch the graph of the polynomial. The first thing we will be looking for here are the zeros. Luckily, this is already completely factored. What that allows us to do is find each zero by setting each factor equal to 0 and solving for x. So when we do this, x minus 1 equals 0 and x minus 4 equals 0 tells us that our zeros are x equals 1 and x equals 4. To find the multiplicity of each zero, since we already have this completely factored, we can simply look at the exponent for each factor. And over here with x minus 4, the implied exponent is 1. That is how we find the multiplicity. So to write it out, we have some zeros, and we have 1 and 4, and we have the multiplicity of each zero tells us, let's see, 2 and 1. And remember the multiplicity, if it's even, the graph that we are talking about in the very last portion over here, use this info to sketch the graph of a polynomial. That'll tell us whether the graph crosses or bounces the x-axis. So if it's odd, the zero or the graph will cross the x-axis at the 0, and if it's even, the graph will bounce off the x-axis when it's 0. Here's the same function. Now we need to find out what the leading coefficient and the degree of this function is. And from that we can tell what the end behavior is. So we can already know what the degree is kind of by looking at the multiplicities of these zeros. Right? The degree here is 2, the degree here is 1, just of each of these little individual pieces. So if we add these degrees together, this is 2, this is 1, the degree will be 3. The leading coefficient here will be the product of the leading coefficient here to the power, the leading coefficient here to this power, times the -3 in front. So we will be getting this -3 right from here. We're going to take the 1 from this set of parentheses, and the exponent there is squared, times the 1 from the second set of parentheses times raised to this exponent, 1 to the first power. And when you multiply all of this together, you get a leading coefficient of -3. And then using the leading coefficient test, you can tell that this function has an odd degree and a negative leading coefficient. So So that means when we are looking at end behavior, that will fall to the right and rise to the left. In this final slide, we will be finding the y-intercept and sketching the graph. Remember, to find the y-intercept, you simply just need to substitute 0 in for x and simplify it down. And we'll see what we get for the y-intercept here. So the y-intercept will be -3 times, if you put 0 into this first set of parentheses, you get -1. Do not forget the square. If you put 0 in the second set of parentheses, you will get -4. And when you multiply all of these numbers together, you will get 12. So the graph down here, the first thing I would like to do is plot all of the points. There is a 0 at 1. Put a point there. There is a 0 at 4. We'll put a point there. There's a y-intercept at 12. Put a point here. And now we can start forming this graph. First step would always be to plot your points. The next step is to work with the end behavior. From our previous work, we know that the end behavior is rise left and fall right. So now we know that somewhere over here, and I'm going to do the graph in blue, we're going to be falling right, and over here, closer to the actual points, we're going to be rising left. So all we have to do is figure out what's happening here in the middle, and that is where the multiplicity of our zeros comes into play. I know this graph is going to come through here and touch the y-axis up there at 12, and as we get closer and closer and closer to 1, the multiplicity of 1 is 2 right here. And what that means is it's going to bounce off the x-axis. And so since we were above the x-axis to start with, when we come down to that 0 and bounce, our graph will stay above the x-axis after we touch that 0. And as we continue along, well, we need to get to this 0, 4, so we've got to curl back down here. And the multiplicity of that 0, 4 was 1 up here at this exponent. So that will cross the x-axis and we'll just meet right up with our falling right end behavior. And there is a sketch of the graph.